Hello and a warm welcome to everyone joining us today. I'm your host Dalvinder Kaur from lovely Professional University. We are excited to have you with us and to look forward to an engaging and insightful session. So sit back, relax, and let's dive into today's topic: Aquaphotomics, water as a mirror of matter and energy. Before we proceed further, allow me to introduce the experts of the day. Dr. Uma Kamboj, Associate Professor, School of Chemical Engineering and Physical Sciences, Department of Physics, Lovely Professional University. Her research interests are visible infrared astronomy and space physics. She had 50 plus research papers, one book, and one patent, and eight copyrights to her credit, and guided eight doctorate and seven master students in the field of astronomy of food products and more. So now I would like to introduce the admission nominee also in this webinar, Dr. Lavleen Kumar Bhagi, Associate Professor in the field of Mechanical Engineering with over 21 years of teaching experience. His vast knowledge and expertise will surely pave the path for attendees, offering valuable information on a wide range of research opportunities, internships, and study or abroad programs in the field of sciences. Before we proceed further in today's session, I would like to request everyone for any questions you can write in the chat box or in the Q&A box, and same will be addressed from my side in the end of this webinar. Now I'm going to hand over this session to our expert, Dr. Uma Kamboj, and it would be an absolute delight to listen from her. Over to you, ma'am.
Thank you, Mom. I welcome all the participants on board. So today we are here with a different, exciting interdisciplinary field, which is very new. It's just 20 years for this field. So the topic for today would be aquaphotomics, water as a mirror of matter and energy. I have been working in the field of interaction of matter and energy from last 10 to 12 years, and I have entered in the field of aquaphotomics. Now, what is this aquaphotomics? We are having few words in it which seems relevant. Aqua, photo, omics. So aquaphotomics is like reading water spectral language to understand the surrounding matter and energy conditions. Let's first understand this word before diving deep into this topic. Aqua means water. So it represents water, which is there in everything. It's in our body, maximum portion 70%. It's there in foods, it's there in vegetable, it's there in all the materials which exist around. Therefore, when you study aquaphotomics, you actually study everything. Photo. Photo means light. Here, especially, we use near infrared light. We study that when light interacts with matter, the matter can be anything. How does that matter respond to the incident light? And we study the patterns in water. Omics. Omics is a word where it is studying a comprehensive study, studying the entire spectrum of interaction. Therefore, aquaphotomics, it is a comprehensive, systematic study of how water, which exists everywhere, interact with light, and it reveals the information about environment, about perturbations, about biological system, everything. So let's check and deep dive into it. We said near infrared spectroscopy. Before moving into near infrared spectroscopy, I hope everyone here know electromagnetic spectrum. In electromagnetic spectrum, with the visible light, we have a spectrum called infrared. And this infrared is divided into three parts: near infrared, mid infrared, and far infrared. Near infrared is the region where you have 700 to 2500 nanometer wavelength, and far infrared is moving up to like 10,000, more than that, nanometers. What is so important in near infrared spectroscopy and why we are using this field and why water? You know, water can talk, water can tell us everything, water can sense everything. Water is not only H2O, it is actually a mirror to the complete surrounding. It can reflect what it sees. Aquaphotomics is a field where you study water by the light and matter interaction. You understand that if water is reflecting the light and water is present in which kind of environment, it can sense that. Due to this, it is relevant. This field of aquaphotomics is not restricted only to physics. It is relevant in complete sciences. It is relevant in physiotherapy. It is relevant in food technology and everywhere. The concept of aquaphotomics was first coined by Professor Rumiania Zenkova from Kobe University, Japan in 2005. As I just told you that it's 20 years, we celebrated its 20th anniversary in Japan. It studies why water and light interaction in the infrared region. It's a new field where the Professor Zenkova talked about how water changes. So let's talk about some basic principles. You would be studying the bands from 700 to 2500 nanometer. There are some specific wavelengths which reflects water bands, which reflects water changes. Water, because it's a universal solvent, it's existing everywhere, you can study everything, and it is also which is sensitive to everything. I hope you have heard about that water can change its structure depending upon the environment it is kept in. If you're keeping water, if you all can remember, whenever there is some ritual, you keep water in a bowl and then you do the vibrations, and then water which was there during the whole vibration is considered as important because it can sense. It is sensitive to temperature, it's sensitive to light, it's sensitive to vibrations, sound, music, emotions, everything. And why light? Especially near infrared, because it is non-destructive in nature. It does not destroy the basic structure of the material on which it is falling. So what you mostly do here is we have a source, light. We have some material, right? And we have a dispersing element. The basic dispersive element we all know is prism. When you fall the light on prism, it is scattered into the white light. It's scattered into 7 colors, different wavelengths. When we use infrared light and you pass it not through prism, through a dispersive element, which can be filters, which can be grating, it disperses in different wavelengths. 700, 800, 900, all the wavelengths are separated. They fall on the sample, and when they fall on the sample, depending upon the resonance, depending upon the vibrations, the molecule, the matter, it absorbs some energy and some is transmitted. After studying the transmitting spectra, you can know everything about that material. This is how near infrared spectroscopy work. It's fast. You don't require any preparation of sample. Like if you are doing some other experiment, you actually need to mix the things together and you destroy that sample. Here you can directly take. Suppose I want to test this water. I need not mix something in it. I can directly put the radiation. It will not destroy the features inside it. You can use it online. We have small instruments available. You can go directly to the field, measure the soil, measure the palm, measure the tissues directly, and then it can be analyzed. So what basically happens, let's come to a bit of physics into it. When you have light, it falls on the material, right? What happens? There would be vibration, there would be excitations occurring. So if incident light is in resonance with that, when the light is such that the molecule can transform from fundamental, that is the ground level, to the first excited level, which is called fundamental vibration, then that much energy is absorbed and you can study the fundamental vibrations. If the incident energy is such that you can study from ground level to second, ground level to third excited level. These are called overtones. First overtones, second overtones. Therefore, depending upon the energy, depending upon the light which is incident on the material, your material can absorb in overtones and combinations. So what you get over here is, here on the x-axis, we are having wave number. Wave number and wavelength are related to each other. So up till point of like 4000, this part is near infrared. This is mid infrared. And then we have far infrared. So whenever a molecule is excited with mid-infrared region, it undergoes fundamental vibrations, ground level, first excited level. And you can study these spectra. You can study the structure over there. When you incident a light from near-infrared light, what happens over here is you can study the overtones, ground level to the first excited level, ground level to the second excited level. So these are first overtone, second overtone, and so on. So you can study the structure with more depth by only taking the absorbance spectra. So in near-infrared spectroscopy for water, again a major thing, you need not undergo the complete spectrum 700 to 2500. Rather, we can work only with 1300 to 1600 nanometer. A small portion. It means somewhere around this portion. This is in wave number in the first overtone region. So you don't need a bigger instrument. I hope you are aware that if you need a full infrared spectrometer, it costs very high. It's near crore. But if you take a small instrument which falls under 1300 to 1600 nanometer, it falls to 7 lakh, 8 lakhs. So now I have the absorbance spectra, right? This spectra is in front of me. What next? Wherever these peaks are there, these peaks are telling that there is absorbance. One can study these peaks and know what bond, what structure is present over here. This is the concept of spectroscopy. Then to analyze it, you do some regression and then you only pick up the water bands, which is known as aquagrams. So you can measure all the bonds, XH, CH, NH, SH, OH, and I think these are the bonds which are present in all organic compounds. So using the study of aquaphotomics, which is a small part of NIRS, you can non-destructively, in a low cost, in a rapid manner, test everything. So you work on overtones, you work on vibrational energy levels. So I hope till this point you understood that it's not only physics. We are into physics and chemistry and mathematics till now. Let's apply it everywhere and let's understand aquaphotomics in a better manner. You can test everything. Aquaphotomics can be used by people in food industry, biological sciences, chemical sciences, physiotherapy, medical sciences, everywhere. So what happens? Whenever light falls on the material in the range of 1300 to 1600 nanometer, there are spectral band changes because you're putting light on it, right? So it is basically perturbations. It is basically the changes and the water band change. You know, water is not H2O. It has so many structures. It may be tightly bound, it may be loosely bound. And then only by understanding the spectra, what you can see is aquaphotomics. Let's understand this image. Water is a mirror. Water, material, light, it falls and perturbations are given. What does perturbation mean here? It can be you are changing the temperature. It can be you are changing the concentration. I'm talking in every field. In physics, you may change the temperature. In chemistry, you may change the concentration. In bio, you may change the quality. You adulterate it, right? In medical physics, you may change the sound perturbation and any perturbations. Then you observe the spectra. This is the spectrum. From the spectra, wherever you get peaks on the specific wavelengths, these wavelengths are there for sure in near infrared region, you can pick up the bonds. Depending upon the vibrations, because of these wavelength, it can undergo different vibrations. For example, if you are into sciences, you might be knowing that you have symmetric vibrations. These are H bonds. Here it's O. So you can have symmetric vibrations. You can have asymmetric vibrations. You can have scissoring vibrations and many more. And with every vibration, water changes. Then these specific absorbance bands are studied in the form of aquagram with water matrix coordinates. So what are these water matrix coordinates? These were given by Professor Romania, that there are basically few wavelengths from 1300 to 1600 nanometer which can be studied. This is a depth study. So from 1300 to 1600, the complete band is divided into different small bands. And what we have over here is, though they all are water bands, but they talk about different things. Water solution, symmetric vibrations, free groups, bounded groups, and many more. And when you plot all these things, what you get is aquagram. So in this aquagram, what you're having is, I'll give you a brief view for this image. This is your spectra, right? These are wavelengths, then you get a spectra. This is for the complete range, and we can see there are maximum perturbations you can see in NIR from 1300 to 1600 nanometers. So on the boundary, you can see the wave numbers. From here to here, center to out, it's like absorbance. Now what happens, this aquagram can be derived by the spectral changes, and these water matrix coordinations can be studied. Now let's see what's the beauty of it. When you are only studying this part, here it is about loosely bound water structure. It means if your absorbance is coming high in this region, your material is having vapor interactions. It means it's loosely bound. If it is falling in this range, it is free and water which is there with vapors. So this is water vapor interactions. So it is totally loosely bound. Now the hydrogen bonding is a bit stronger. This region, here it goes the phase transition. Vapor, water vapors, and then water. So now water is in the stage which you normally look. But from this range, if you go higher towards 1500, it is going towards strongly bound structure. So water-water interactions are increasing and it is becoming, you can say something like ice, strong bound. And on the upper side, till 15 to 1555 or so, you have water-water strong interaction. It means water is now behaving as ice. So what you normally do is, we take the spectrum, we take only 1300 to 1600 wavelengths, and then you make aquagrams. This structure is known as aquagram. If the absorbance is in this region, it means water in that material is loosely bound. It is in the vapor stage. If it is in this region, it means it is a bit tightly bound, water vapor transitions. And here it is something like water and then going towards ice. So from this 1300 point to 1600 point, you observe 6 transitions. Normally we say there are few phases, right? Water itself have 6 phases. Let's have a look on all the phases. So the first phase in the starting wavelength is known as tightly bound water. It means if I talk here about these blue lines are for a sample which is having open structure, and this side it is tightly bound structure. Okay, so these wavelengths show us that there is tightly bound water. If you further go, you have loosely bound. The third one is water, normal water. So it is lying in this range. Then you have water vapors, then you have liquid, and then you have ice. Let's have this image as a combined one. So we have tightly bound waters here. Then you have loosely bound water, then you have free water, then you have vapor. So what happens now? I hope you understood now. Suppose I am taking water, I'm keeping it here, and now I'm shouting on this water. So what I'm doing is I'm increasing the energy. Sound is being given to this water. So the water structure will change. When you measure it after shouting it, right? It means not good words. You're shouting badly. And you take the spectra of this water, it would be totally different. On the other hand, if I am talking smoothly, I'm talking positively to the water, meditating, the structure will change, and which can easily be observed using spectroscopy, the complete near infrared spectroscopy. For your reference, I have mentioned the papers here. So these are all the papers of professors in Goa who started this, and I'm happy that I was one person to be present during the 20th anniversary of Aquaphotomics. So I hope you understood that till this point, what is this Aquaphotomics? And now, let it be from any field. Water is everywhere, right? What is in our body, food, materials, plants, bio things, everywhere. Therefore, aquaphotomics is having a lot of applications. You can use it to test the quality of food products. You can use it to test the quality of plants, right? Which part of plant is having structured one, which is loosely bound. You can test it on medical. You can test it on environment. You can test it on physiotherapy. So let's start with case studies. The reason of introducing case study was first after understanding what is aquaphotomics. Now you can understand where to apply and have it really been applied. Okay, so first let's take an example of agriculture. What these scientists did was these researchers they picked lettuce because it's not in India, right? In India, you can pick up cauliflower or any other vegetable, and they wanted to test the freshness. So they took lettuce, they stored it for different days, and then they monitored the changes. So let's see the changes. I hope you're ready to view the changes. So this vegetable was stored for 6 days long. After 6 days long storage, it was checked after first day of storage, second day of storage, and so on. Its spectra was taken. And what does the result show? You can have a look over here, right? The first one is without storage. I'll make this bigger so that we can understand better. The purple is first day. So you can see the first day circle is symmetric. It is not showing bounded water bonds. It is not showing free water bound. So the blue one, the purple one is symmetric, normal water. Now with increase in the storage, in the second day of storage, now these two graphs are, this is for the inner leaves and this is for the outer leaves, something like our cabbage, right? So you can see the structure being changing, light blue, then green, orange and red. You can see how it is changing, light blue, green, orange and red. Which side it is shifting? It is shifting on the bounded side. It means with storage, water which was normally behaving, this purple circle, it shifted towards tightly bound. Why? It's understood temperature is coming down. You can test it, right? So you can test, is it having tightly bound water structure? It is having loosely bound water structure. But there is a big difference. The both shapes look similar, right? But in the second shape, you can see there are loosely bound leaves with loosely bound water structures. Why? Because these are the outer leaves also. So by a simple experiment, not destructing it, not giving any treatment to it, just by checking a small spectra, you could see the small machine. This is NIR spectrometer. Using this small machine from 1300 to 1600 nanometer, you can sense it. So yes, water is a mirror. And this study was done in 2023 by Zenkova professor's team. It's not only agriculture. Let's go to the next field, water and sound healing. What was done over here was effect of music was tested on water, right? And then it was checked that can water retain that memory, as I gave you an example. So here it's not just an example, rather an experiment was done. The first one and the second one, PW stands for pure water. It means we have three lines, and you can see how water changes, right? Pure water, mineral water, they give different things. So the black one is controlled one, you gave no vibrations. The blue one is pure water, and orange one is mineral water. It was taken in two beakers, right? In the first beaker, 432 hertz frequency was given to the water. In the second, 440 hertz. Now, question is why sound of the specific frequency was given. This is the common frequency which is used in musical instruments, right? So it was given. What can you see here? You see at 432 hertz, water changed from normal structure to tightly bound structure. But at 440 hertz, water changed from normal structure to loosely bound structure. It became more free. Rather in 432, it became strengthened. Though you can see it as a water, but its bonds inside the water, they got closely bound. Further, this is not only the story where it stops. You can see there is difference when you use a pure water blue and mineral water orange. Though they are behaving in a similar manner, but their absorbances are different. It means here mineral water is less affected as compared to the pure water. It might be the reasons that there are mineral controlling and some other things, but yes, if you increase the frequency, it goes to loosely bound structure. Therefore, whenever you are drinking water, take care it was under which sound vibrations. So this was a research which was done by Professors Enkova and team, that is effect of audible sound on water molecular structures, and it was published in Molecules in 2022. So from food, it started with physics, chemistry, and statistics, applied on food, now applied on sound, healing, vibration. Let's check another, meditation. So there was analysis which was done with pre and post meditation water sample analysis. And what was observed, what was done basically in this experiment, two participants were done. They were given water samples, right? They were told to meditate, right? They were given water and they were told to meditate. After 1 hour, they were tested. So two people were there, one was control and another was which was given a healing touch also, right? And then after 1 hour, spectra was observed. And it was observed that meditation during 1 hour, it could produce the changes in the water structure. This is the reason our ancestors always told that you should meditate to make your body calm, because voice is also affecting. When you're eating, when you're drinking, or you're with yourself, water is everywhere and it is affected by vibrations. Further studies which are done in this are adulterations are tested. You can take any material, for example, juices. One juice without adulteration and another with adulteration. You can simply take the spectra from 1300 to 1600 and you can check the waves in it. Water structure changes drastically. Isn't it interesting? Water, light interactions. So what we observed over here, the complete electromagnetic spectrum, we are decreasing it to a small spectrum, that is near infrared spectroscopy. Small part of that is 1300 to 1600, which is having 12 water spectral bands, applying mathematics on it and analyzing everything. This is the power of water. This is the energy of water. This is a reason we started this presentation by saying that water is a mirror. Water is a mirror. I hope now you understand why I use such big words, that water is a mirror of water and matter and energy. You know, like in bio, we study DNA and you can understand the structure. Similarly, in aquaphotomics, you can read the water structure, you can make the aquagrams, and you can check how it is behaving. Is it in vapor-like structure? Is it in ice structure? Is it free water? Is it in between water vapor phase? Is it in between water ice phase? So this is aquaphotomics because we have a wide application of it. So it would be great that if we can discuss about it and have queries from your side. And it is having application in lot many things. So ending it up here, thank you for listening to the webinar, but I don't want to stop here. I want to have a discussion so that we all can discuss that yes, it can be used for everything. So aquaphotomics can access whatever you wish to. Thank you.
Thank you so much, Dr. Uma Kamboj. It was a wonderful session. So now I would like to request our admission nominee, Dr. Lavleen Kumar Bhagi, to be on the screen. Over to you, Dr. Lavleen Kumar Bhagi.
Thank you very much, and very enlightened, you can say, presentation by Uma ma'am. Let's start with the admissions detail. Just give me a second. I'll share my screen. I hope my screen is visible.
Yes, screen is visible. You can continue.
Right now. First of all, congratulations, Dr. Uma ma'am, for presenting a paper in Kobe University, Japan, in the Aquaphotomics conference from held in Japan from May 17 to 21st, 2025. Regarding the LPU, let's start with the accreditations and approvals. We have, you can say, UGC recognized LPU with a grant of graded autonomy in category 1, and it signifies its exceptional performance in higher education. And if I go with the NAC, the National Assessment and Accreditation Council, that LPU received the highest NAC grade A++ with the score of 3.68 on 4-point scale, and it is the highest score in first cycle of accreditation among all government and private universities. We have NBA accredited programs also, like MBA we have, and BTech programs we have NBA accredited programs. And if I go with the accreditation, ICAR accreditation, then we have School of Agriculture. In School of Agriculture, we have 8 MSc agriculture programs, along with BSc honor agriculture program have been awarded with ICAR accreditation. And if I go with the NIRF ranking, then we stands the 27th rank amongst all government and private universities in India. And if I say with the discipline wise, then 16th rank in pharmacy, 19th in law, 22nd in agriculture and allied science sectors, 24th in architecture and planning, 38th rank we have in management, 44th rank we have in research and institutions, 50th in engineering, and 11 to 50 band in innovation. And then world university ranking, the Times Higher Education world university ranking, then we have 9th amongst top universities of India, including all government and private universities. And the world university ranking for innovation 2024, we placed 4th rank in India and 126th globally among both government and private universities. Uh, Furthermore, if I add over here the LPU, we proud for India for having the top 200 universities globally. Then LPU is a rank 19th globally, and second in India as per the Times Higher Education Impact Ranking 2024 in the category of quality education. And if I go with the research quality, then we rank 9th among all the top universities of India. And further, we have second rank uh, in the Times Higher Education World Ranking 2024 in the subject of physical sciences. And Semago Institution Ranking 2024, we rank 7th amongst all the universities in India. and it's you can say Seismic institution ranking methodology evaluates universities and research focused institution based upon scientific output as a measure of academic quality. And furthermore, if I go with the subject wise, then we have 43rd SciMago ranking in the physics and astronomy, 30th rank we have chemistry, and 25th in mathematics. These rankings among us all, we can say, from government and private universities in India. And if I go with the QoS world ranking and by subject, we have 19th rank in mathematics, and with the chemistry we have 19th rank QoS world ranking, and engineering and technology we have 15th rank in QoS world ranking. Another accreditations we have for the business school, ACBSP, Accreditation Council for Business Schools and Programs from the USA. ACBSC is a specialized accreditation association for business education, supporting, celebrating, and rewarding teaching excellence. Along with the accreditations, we have approvals also, like PCI approval for the pharmacy programs. For the architecture program, we have Council of Architecture. For the law programs, we have BCI approval. Likewise, we have AICT approval for distance learning and online programs, Institute of Town Planners for planning or planning programs, and then Indian Association of Physiotherapists for the physiotherapy programs, and Punjab State Council for Agriculture Education. And furthermore, the memberships we have, like Association of Indian Universities, International Association of Universities, Institute of International Education. And if furthermore I'm going to discuss regarding the placements and achievements, our student Yashiram secure a, you can say, record-breaking package at 3 crore rupees in global MNC company in Germany. And our final year students getting highest package, you can say 2.5 crore package and 1.03 crore package. And if I go with this thing, if I tell you, more than 1700 LPU students selected at a package of 10 lakh to 2.5 crore and placed in a very renowned companies. We can say our Vamsi Reddy from the BTech in robotics and automation secure a package of 1 crore rupees, and Pavan 1 crore package he got. Then Mahanto 64 lakh rupees, Arjun 62.72 lakh rupees, Abhinesh 54.9 lakh rupees package. If I tell the number of recruiters, we have more than 2000 recruiters hired LPU students, more than 5000 offers from Fortune 500 companies, 350 plus recruiters from of IIT, IIMs, NIT, hire students from LPU also, and 10.1 lakh average salary of top 25 placed students got. And these are the, you can say, a number of students packages, and the company, you can say, Palo Alto, very renowned company, Google, all you know, Amazon, all you know, Moto RQ. So these are the few companies. If I go with this regarding the placements, one of our alumni has successfully achieved his startup Dex Logistic and earn revenue up to 100 crore rupees. Ansh Sharma from BTech Chemical Engineering. Then another student, Ashworth Wongwa, LPU student of Chemical Engineering, has got offer from University of Florida for pursuing the master's program in chemical engineering with the fellowship. Neetu Vishkarma Best Poster Presentation Award in the International Chemical Engineering Conference at IIT Patna. One of our student, Asif Yusuf, clear UPSC Civil Services Exam 2020 with the very you can say a nice rank, 328 rank. Our alumni Soumya Kumari secured UPSC exam with the 502 rank. Anwarullah Ansari has awarded scholarship by DAD for higher education in the Federal Republic, Germany. Aditya selected as a reviewer in renowned journal, American International Journal, and IGSSMET journal. Hasif Abdullah got selected at Leeds UK for higher studies with the scholarship. Our you can say BSc chemistry student qualifies IIT JAM exam with the top rank, All India rank 10. As you know, this you can say JAM paper generally connected for the master's level programs and is being held over for 3,000 seats across 89 PG programs at 21 IITs. Deva Narayan Rajiv from the School of Chemical Engineering and Physical Sciences has been offered rupees 25 lakh plus scholarship to pursue masters in Finland. And Manvi Gupta, our student from chemistry department, qualified state level PCS exam with the rank 76 and deputed as a deputy superintendent of police. Chishmo Dhaka alumni from MSc Physics department. He is the founder, CEO, and CTO at Dhaka Space Technologies, which is a Malvinian space-based technology startup company. Sishodia, student from physics, was selected 2 years with scholarship of 22,416 euros for excellence track program in physics at Johannesburg, Gothenburg University, Mainz, Germany. Devanarayana selected master's program in theoretical physics in University of Turku, Finland, with a 100% you can say fee waiver scholarship. And our student Amal Chandar from BTech Chemical Engineering on achieving an incredible score in the GATE and All India rank, he got 266. Another student from the Department of Physical Sciences, Mr. Aksh Kundu, got selected in the position of scholarship holder for a project Quantum Systems of Informatics Groups in Polish Academy, Poland. Subhash Agarwal got selected with a full scholarship for doing PhD in Kazakh Republic. Akshay got selected in the University of Siegen, North, you can say Germany, for master's program after BSc honors physics. Ayush Arya from BSc honor physics selected for 10 weeks astrophysics space science summer research fellowship in Sweden. And along with the academics, our student performed very well in sports also. Like 13 students represented India in Tokyo Olympics 2022, and out of 13, 12 creates history and won the Olympic medals. And along with this, our students stood first runner-up in the Maulana Abdul Kalam Azad Sports Trophy in 2023, and it's first time ever private university to clinch this title since its inception, 1956. Um, Another, you can say, consecutive year, our student got first runner-up trophy in the Makkah Trophy Games. Along with this, 24 students participate in the Paris Olympic Games 2024. And if I say 21% of the Indian Olympics contingent is from the LPU. And furthermore, 13 students set to represent India at FISU World University Games 2025, which is being held in Germany. And if I let's go live, if I going to show you how you can check it out, all the details which I have discussed over here. Just give me a second, I'll show you how you can check all the details from our website. So you need to go first, you need to go to the website. Like if I go to the type, if I go Google, suppose I go with the Google, I type YLPU, then all the things you can see over here. So over here you can see, just need to click this page and all the information which I have discussed over here: ranking, accreditations, 360-degree industrial involvement. That's the key factor for this huge number of placements we have, and renowned companies with the package of with the more than 10 lakh rupees package, we can say, on an average. Then we have 360-degree industry involvement, means live industry projects we have, mentoring we do, industry collaborated programs we have, academic collaborations we have. So these things are to be very, you can say, uh, make the students more focused. Then we have innovation and entrepreneurship. Then we have the extracurricular activities, career pathways. It's depend upon your interest. If you choose career, government jobs, higher studies, research, entrepreneurship study, accordingly our curriculum will be your pathway you have selected. Then these are the placement details which I have discussed with you. You can click over here, view placements, then you can see all the details over here. The number of companies, number of how many students offered from Fortune 500 companies, average salary package, and the companies listed over here, and the companies recruiting at LPU. The graph is continuously going the upward trend, you can say. Then these are the learners from the leaders, the employers, like this way. All the things you can see over here. The packages. If you want to know for more detail over here, you click over here. No more. Then you can get the more details from here. So this is how you can check the website. Further, if you want to know more about, suppose you want to know the BTech chemical engineering, okay, so you go to the admissions, and then you go to the, if you want to know the school of chemical engineering and physical sciences, then go to the admissions. Sorry, you go to the admissions, then go to the chemical engineering and physical sciences. Then this is our school web page, uh, and over here you get to know all the details on this page, right? The faculty detail over here, the experience they have, the interested area for the faculty members. So all the things you can get to know from the web page. Guest lectures, like the guest lectures in this case, you can see Dr. Sushil Kansal, professor at Punjab University, Chandigarh. And further, if I scroll over here, then Professor Ajay Ghatak, uh, very renowned name in the quantum mechanics. Then Professor H.C. Verma, uh, then you know this thing. Uh, uh, this is very renowned, you can say, work in the uh, uh, subject of physics. Then so these are the things you can see. And if you want to know the detail of the particular program, then you go to the regular programs, go to the admissions, then go to the regular programs, and then you can search over here. Like you go to the discipline. Under the discipline, suppose you want to know about the BTech chemical engineering, you click over here, you choose the stream chemical, and then this is the BTech chemical engineering, and then from here you get to know all the details, like from the eligibility. As you know, eligibility, we require 60% in your 12th class, and the subject you must have studied in your 12th is English, physics, chemistry, and mathematics. These four subjects must you have studied in the 12th class. And then there is a test. Either you qualify our LP Nest, or you qualify JEE Mains, or you qualify CUET. So any of these tests, if you qualify, then you are eligible if you got the, if you satisfy the academic eligibilities. And further, you can see the fee and scholarship details from this page. Curriculum details, you can see first year which subject you are going to study, second year subject, third year, and final year subject you are going to study. This way, further this, and further engineering minors, we have language electives we offer, pathway electives. Pathway electives, I told you, in the government job. This way, pathway electives, government jobs, we have higher studies, and accordingly you choose the basket. In the open minors, we also offer the subject which is not directly linked to your discipline, but as per your interest you can opt these subjects, like 3D printing. If you want to, you have an interest in this, geography, history, along with the BTech chemical engineering subject, you study these subjects also as per your interest. And then you have the, if you want to know the fee structure and the scholarship benefits we are offering to the you can say toppers of the your qualification, like 12th class. If you have board topper and top 20 rank holders, we give the 100% program fee waiver. And with the percentage of 98 and above, we give 65% scholarship benefit, and with this scholarship benefit your program fees will be only 49,000 rupees per semester. Accordingly, we consider JEE percentile also, and this way you can see the scholarships we are offering to the students. And further, other scholarships you can see over here, the scholarship on the basis of percentage in qualifying exam, this I have already been discussed with you. Scholarship on the basis of LP test, scholarship on the basis of CUET UG test, scholarship on the basis of JEE means, special scholarships for education board toppers, I have already told you. Then financial aid to Shikshak Samman Anudan. Here we, if the parents working in the teaching sector, they are teachers, regular teachers in the recognized board schools, then we give the 20% over and above scholarship to the students also. Then financial aid to Rakshak Samman Anudan. Uh, this specially scholarship given to the defense dependents on the defense personals. And then financial aid we offer need based students, orphan person with certain disability, this we also consider, but you need to consult with our counselors before. uh, you can say, if you have any doubt, you can call us. And then how you apply, this is the process. You need to click over here, apply now, this button is over here, and over here this is also there. So it's up to you. Suppose I click over here, apply now, then you can see admission.lpu.in web page will open, and there is two options, register and login. If you already registered, then you simply click on login. If you have not registered, then it's a you put your name, email ID, and then mobile number with the state, city, qualification, like this way. Suppose your previous qualification is 12th and you want to select the BTech chemical engineering and that engineering. So this way, very simple way to register. And further, if you have any doubt, you can go to our this website, and there is a contact us. This contact us um, option is there, and over here you can see the phone numbers, WhatsApp chat number, email ID, all the minute details you can find over here. So with this you can call us. Yeah, this is all about our admissions. Thank you, ma'am. Thank you very much.
Thank you so much, Dr. Lavleen Kumar Phagi. Dr. Uma Kamboj and Dr. Laveen, can we take the questions now?
Sure, ma'am.
Thank you so much.
Yes.
Thanks for giving me a chance to address your questions. Now, let's start with the first question. Our Dr. Agniba Das is with us. Dr. Agniba, you can ask directly your queries, your questions to our expert, Dr. Uma Kamboj. Yes, Dr. Agniba. Yes, Dr. Agniba. Okay, in between, okay, Dr. Abniba is asking, I want to know how to plot the aquagram plots.
Okay. Thank you for the question, Dr. Agni. To plot aquagram, it is the simple step. First of all, you need to take the infrared spectra. As I said, that take the complete spectra, or you can take a small instrument and 1300 to 1600. Then you need to calculate the aquagram. That is what you need to do for that. First, you need to normalize the spectra. If you are from this field, you would be aware that you cannot directly use NIR spectra. What we do is we normalize it. We apply pre-processings. So after applying pre-processing, normalizing it, then you subtract mean of those values and divide by standard deviation. This will give you the aquagram value. So now either you can do it directly in Excel, because now we don't have a software which can calculate aquagram directly. Yes, you can do it, and it's a simple formula: normalized spectra minus its mean divided by deviation. If I'm not wrong, I think I have showed it in one of my slide also when I started it. So you just need to like get it from NIR spectra. Number one, get the spectra. Number two, calculate the ekpagram. And number three, plot it and check what is happening to it.
Thank you so much, Dr. Uma. I hope Dr. Agniba, you got your answer from our today's expert. So Gurpreet is with us. Gurpreet is asking, in what ways can water act as a mirror to reflect changes in surrounding matter or energy, and what practical applications does this have in biology or agriculture?
Thank you for your question, and I hope you were listening to the PPT. It has lot many applications in agriculture. You can check the quality of your plant if you are working on like production of some plants. So you can check that is your plant ready to harvest. Secondly, if you are there in food technology, like we took an example of lettuce, so we can check the vegetables, fruits in a non-destructive manner, and you can see that is it fresh or it's not fresh. Is it ripen or not ripen without cutting it out, right? So it is a non-destructive way. Another application in agriculture is you can check the soil quality, that which soil is having more water bound. It means it will release less water, or it is having loose water bound structure, means you can sow a crop which needs more water. So it can be used in soil quality, foods, fruit, juices, plants, in all the agriculture thing. It is having a wide variety in agriculture, and I myself is also working in that field. I use it for adulteration of spices. I use it for adulteration of citrus juices.
Thank you so much, Dr. Uma Kamboja. I hope, Gurpreet, you got your answer from our today's expert. So Dilpreet is with us. Dilpreet is asking, Dr. Loveleen, do LPU provide the residential facilities also?
Yeah, yeah. Dilpreet, we have a largest residential facility in campus, and if you want to know more about the hostels, about the indoor facilities we provide, you can go to our website. I'll show you how you can check from our website. Just give me a second. I'll share my screen with you. Uh, Sharing option, I think. Oh yeah, thank you, ma'am. So over here, you can go to this admissions tab over here, and then these are the residential facility option over here. So you can see, so over here you can see all the things we have in the style of the hostel, indoor sports facility we provide, gym facility we provide. And suppose we want to know more about the this residential facility, and then scroll down over here, and then you click over here residential facility, and these are the different type of sitters we offer to the students: four-seater, three-seater, two-seater, one-seater, like this way. And here this is the further 3D image of the standard four-seater room, and these are the facilities we provide in the hostels and in the residential room. And if you go to the apartment, then we have the apartments also, four-seater, three-seater. It's depend upon your choice. So this is how you can check the residential facility. And if you want to know more about the mess facility, here you can click, and these are the mess facilities we offer to the students. Again, we have laundry charges. These are the optional. It's not mandatory for the students to pay. If you opt laundry, then only you need to pay. Similar, if you go for the indoor sports stadium, if you are very interested in the sports, then only you need to pay. Otherwise, we have outdoor stadiums, very lush green outdoor stadiums we have, and then the no charges over there. If you suppose found of playing cricket, then we have very you can say big cricket ground along with the net practice grounds. We have outdoor table tennis, lawn tennis grounds. We have basketball grounds. We have volleyball grounds. So no charges for there, right? This is how you can check the details for residential facility. I hope I have answered your query.
Yes, thank you so much, Dr. Loveleen. I hope that Preet, you got your answer from our today's expert. So I hope all the participants got their answers from our today's experts. Once again, thanks to Dr. Uma Kamboj and Dr. Loveleen Kumar Bhagi. As we come to the end of this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information for better decision making regarding admissions. If anyone wants to access this webinar again, they can visit our website, that is lpu.in, or can be accessed on YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a great day.
Thank you.